So hello everyone, in the previous session of Heaps part 1 we have studied what is a priority queue, operations involved in a priority queue, and we have seen how priority works for primitive data type, for objects, all those kind of things. After understanding the concept of priority queue, we have seen what is a heap, properties of heap, and what diagram, what structure we call it as a heap, and what are the conditions for a given binary tree to be a heap. And we have seen the operations involved in it, like how we perform insertion, removal, peak operation, all those kind of things, and I have showed you the code also. Now in this, what we're gonna do is we are gonna solve the questions based on the concept of heap. So let us start with our first question, and the name of the question is heap sort. So user will give me a unsorted array, and using the concept of heap, I need to convert it into a sorted fashion. I need to convert this array into a sorted array. Now we have seen bubble sort, we have seen algorithms such as bubble sort, insertion sort, selection sort, and backtracking algorithms like merge sort, quick sort. And in that I have shown you that we follow a fixed approach in sorting algorithms. Let's say that merge sort will have a fixed approach, that is, you need to break your array into two different parts, and this breaking will continue until you get a unit element. Similarly, in heap sort also we follow a set of steps, and by performing these steps we get a sorted array. So in the question, what is the basic asking of the question is that user will give us the unsorted array, and we need to convert that unsorted array into a sorted one using the concepts of heap, that is known as heap sort. So as I said that each algorithm will have a set of steps, and by just performing the set of steps we can perform that particular sorting technique. In bubble sort, what we used to do, we used to compare this particular element with the rest of the element. In merge sort, we used to break elements. Similarly, in heap sort, what we will do is that heap sort is a two-step process. You have to remember this. Heap sort is a two-step process. In the step 1, first of all we will visualize. I have told you that, and this is the fourth time I was telling you this, that we visualize a heap in the form of a binary tree, but we implement it in the form of an array. So here the user has given me an array. Now I am imagining it in the form of a binary tree. After imagining it in the form of a binary tree, my first step will be I need to convert that binary tree into a max heap, right? So the first step is, if I want my array in ascending order, if I want my sorted array in the ascending fashion, then I will create a max heap. Else, if I want in descending order, if I want my sorted elements in the descending order, then I will create a min heap, right? So the first step will be, whatever the array you have been given, you need to convert it into a max heap. If I want this in ascending order, I am sorting my elements in ascending order. That is why I will convert my given array into a max heap. So let us visualize this given array in a binary tree format. So 1 will come here, after 2, after 4. This is how we will visualize a given array in binary tree format, right? For heaps, for the concept of heaps, this is how we will visualize it. Okay, after 5 will come here, after 3 will come here. So you can see that this given structure is not a max heap. This is not a max heap. So what we will do is that we will perform some operations, and by performing some operations, first of all, the first step is convert the given array into a max heap. So by performing some operations, I will tell you what are those operations. We have studied those operations. So by performing those functions, by calling those functions and performing some operations, we will try to convert the given array into a max heap. This is my first step. So what are the operations we need to perform? So to convert the given array into a max heap, you need to remember this. For all the non-leaf nodes, I will call heapify function. And in the heapify function, I will make a slight change, and that slight change is that if you go to the previous video of heap part 1, you can see that I have created, in the old session I have created min heap. So in the place of less than or equals to, I will put greater than or equals to. By just changing this small thing, my whole heap structure will get changed and I will get a max heap out of it. Okay, so in the previous session I was creating min heap. Now in this, by just changing the less than symbol to greater than symbol in the heapify function, my whole heap will give me a max heap. Okay, so I will create for all the non-leaf nodes, I will call heapify function, and my heapify function will make the given array into a max heap. So this is the first step. For all the non-leaf nodes, you can see that 1 is a non-leaf node, 2 is a non-leaf node. A non-leaf node is nothing but a node which is having either left child or a right child or both. If a node is having children, then it is not a leaf node. Okay, so for all the non-leaf nodes, I will call my heapify function. So first of all, I will call heapify function for these 3 elements, and among these 3, which one is maximum, I will take that. And this recursive function call will continue until I hit my base case. That is, if I am hitting my leaf nodes, that is my base case. If I am hitting my leaf node, then I won't do any recursive function calling. I will stop my recursive function calling there. So first of all, what will happen is that if you try to visualize my heapify function calling, my step 1, this will happen, right? This is what in the function it will happen. So this is the array I am having, right? So first of all, my heapify function will recursively call and it will come to the base case, and this is my base case. This will become my base case, and in these 3 nodes, you remember that in the heapify function, in the lecture 1, I have shown you that among 3 nodes, which one is minimum, I am taking that minimum node in the session 1, because in that I was creating min heap. Now in max heap, what I will do is that I am having 3 nodes, and in these 3 nodes, which one is maximum, I will take that node and I will replace that node with the root node. So here you can see that among 2, 5, 4, which one is maximum? 5 is the maximum node. So I will take 5 and replace it with 2. So my heapify function will replace 5 with 2, root node with my maximum element. Okay, so 5 will come here, after that 2 will come here, after that 4 will come here, after that 4, after that here also 4. No, I think this value is 3 and this is 4. Okay, now I will call my heapify function for the parent function call. For this, I will call my heapify function now. So in this 1, 5, 4, in this 3 nodes, which one is maximum? 5 is maximum. So 5 will get replaced by the root node. So here the replacement will happen between 1 and 5. So here 5 will become my root node and 1 will come here. After that 2 will come here. Again 4 will come here. After that, sorry, this is 3. After that 4 will come here. Now you can see that here I will check again whether the condition of heap is satisfied or not. So if you observe this structure, you know, this in this, the parent, the main root and the left child and right child are satisfied. It means that the parent value is greater than this. But if you observe this, that the parent value is less than the child value, it means that it is not following the property of max heap. If it is not following the property of max heap, again I will call my heapify function, because the work of a heapify function is to fix a heap. So this fixing will continue until I get my max heap and the whole heap got fixed. Until this 2 parameters got hit, I will recursively call my heapify function. So what heapify function will do is that my heapify function will call heapify for this array, for this 3 elements. So here 5 will remain the same, but among 1, 2 and 3, which one is maximum? 3 is maximum. So 3 will get replaced by the root node. So 3 will come here, after 4 will be in the same position, after 2 will come here, after 1 will come here. You can see that now I have achieved my max heap. So like this, my step 1 will continue. Here in the heapify function, what I am doing is that first of all, whatever the user has given me array, I am creating a max heap out of it using my heapify function, and my heapify function will recursively call for all the nodes until I get my leaf nodes. If I am getting my leaf nodes, then I will stop my recursive function calling of my heap. So this is my step 1, and the step 2 will be replace step 2 will be replace the first element and the last element. Replace the first element with the last element, and here you can see that this is my array, right? So if you draw for this max heap, if you draw the array, then the array visualization will be 5 3 4 2 1. Okay, this is my array visualization for my max heap, right? So this array got converted to this now. Okay, so after it, the second step will be I need to replace this with the 5 with the last element. After replacing with the first element to the last element, the second step, first process will be delete the last element. After that, 2b will be fix the heap. Again call heapify function, because when you delete the last node, your whole heap will not follow the property of a max heap. Okay, so again you need to call recursive function calling. So I hope I have understood. I will show you a dry run. First of all, if you are clear with step 1, that is whatever the array user has given me, I am converting it into a max heap. If you are clear, we will go to step 2. So going to step 2, let me clear the whole screen. So here, this is the max heap I got, right? 5 has came here, 5 is here, after it 3 4, after it 2 and 1. This is the heap I got, and if I draw the array for this, you can see that 5 3 4 2 1. This is the max heap I am getting. Now what is the step 1? Step 1 is whatever the array you have given, you need to convert it into a max heap using heapify function, and heapify function will call the function for all the nodes except leaf nodes. So this function will call heapify for all the nodes except the leaf nodes. Okay, so first step is completed, and after completing the first step, this is my max heap. And after getting max heap, the second step, the first step will be I need to swap first node, first element, and the last element, This is my step 1 in second. After it, the second step will be, the 2b step will be delete the last element. Whatever the element you have swapped, delete that node from your heap. And after deleting, you can observe that your heap become unbalanced. So to make this structure a balanced heap, a balanced max heap, I will call my heapify function again, right? And if you notice, as you delete the elements, you will, let's say I'm adding it in the output screen, or I'm adding it in an array. So as I add, you can see that you will get the elements in a ascending order. Like this, heap sort will work. So I will show you the step 2. In step 2, what we are doing is that, let's say that this is my heap. This is the max heap, right? And its array visualization will be this. So my second step 2a is what it is telling is that you need to swap the first element with the second element. So swapping will take place. If you observe that 1 will come here and 5 will go down. So 1 will be here, after that 3, after that 2, after that 5, after that 4. And my array will become something like this: 1 3 4 2 5. And the second step, it is telling that delete the last node. After swapping, delete the last node. So here, let's say this is my output screen, so I will delete the last node. So let's say I have deleted and 5 has came here. After deleting the last node, my heap will become something like this. Heap will become 1 will be here, after 3 will be here, 2 and 4, right? Now after this, you can see that it is not a max heap anymore, it is an unbalanced heap. If it is an unbalanced heap, then call heapify function. So I will call heapify function for this 3 nodes. So 4 will become the center, after 3 will remain the same, and 1 will come here, after 2 will be here. Now if you see, my array looks something like this: 4 3 1 2, right? 4 3 1 2. Now here again, swap the this is a basically loop. I will put this second step in a loop until my whole heap got empty. I will keep on running this loop. So again 2 will get swapped with 4, and 4 will come here. So my array will become 2 3 1 4. So here you can see that 2 will come here, after 3, after 1, after 4. Okay, now delete the last node, and print it. As you delete, print that thing. So 5 will be here. Now you can see that the elements we are having is 2, 3, 1. Now again call the heapify function. So heapify function will make this heap something look like this. 3 will come here, after 2, after it 1. Now you can see that here the array, if you think of array visualization of this diagram, 3 will come here, after 2, after 1. Again swap the element with this. Now after swapping, my array will become something like this, 1, 2, 3, and its diagrammatic representation will be 1, 2 and 3. Now here what is the last element? 3 is the last element. Delete it and print it. Now after it, my elements in the heap is this 2. Now again call heapify function. By calling heapify function, 2 will come on top and 1 will come here. Now if you see, you can see that 2 and 1, right? This is the heap I am having. Now you can see that if you swap, you will get the same element 1 and 2. Right, after swapping I will get, and if you think of the visualization of this element, 1 is on the top after 2. Now again remove the last element and print it. So I will print 2. Now the last element I am left with is 1. If there is one element, then remove that element and print it. You can see that finally my heap is empty. If my heap is empty, then stop the iterative process and see the output. By seeing the output, you can see that I got the given array in the sorted fashion. You can see that this is the output I am getting, and this is the input I got, which is unsorted fashion. And if you observe the output, you can see that I got the output in the sorted fashion. Like this we apply heap sort. So you have to remember that whatever the array I am giving, the first step will be convert that array into max heap, and the second step will be take that max heap, take the first element in it and the last element in it, swap both of them, and after swapping, delete the last node. Whatever the last element you are having, delete that element, and as you delete, print it or add it in an array list. Later you can print it, right? Okay, so after deleting the last node, you can see that your whole heap is disturbed. Now to fix that, call heapify function. So these are the two-step process. I hope you have understood. Now let us code this thing. First of all, I will create my function public static void heap sort. Heap sort, in this I will get an array as my input parameter. Right, now step 1 will be, I need to create heap sort, I need to create max heap, right? So for creating max heap, I will run a loop for half of the element, and for half of the elements I will pass heapify function. I will call heapify function, and this heapify function will take care of creating max heap. So first of all, let me calculate the overall length. So n is equals to arr dot length. Now after that, I will run a loop for int I is equals to n by 2, and I should be greater than or equals to 0, and I minus. Now in this, what I will do is that I will call my heapify function, heapify, and I will pass my array arr after the given index, after the size of the array, right? And I will show you how the heapify function works, but for now I am creating the heap sort, and this is the process of creating max heap. Now after creating max heap, my step 2 will be first of all take the first element and the last element, and you need to continue this iterative process until your heap becomes empty. So I will run a loop for int I is equals to n minus 1. I need to take the last element, right? That's why I am coming from the last element. Int I is equals to n minus 1, and I should be greater than or equals to 0, and I minus. In this, first step will be swap step. So I will create int, here let me create int temp is equals to arr of 0. I will store the 0th element of the array. Now after it, I will store arr of 0 is equals to arr of ith element, that is the last element. After it, arr of I is equals to temp. So this is how I will swap the first element and the last element. After swapping, I need to delete my given heap, right? I need to delete whatever the user has given me, the given value. I need to delete the last element from my array. So what I will do is that I will call heapify function, and heapify function will delete the last node. Okay, so here I will call my heapify function, heapify arr 0 and ith element, right? So here I am passing the 0th node after the last index as I, and this heapify will automatically fix the heap and it will delete the last node. Okay, now let us define heapify function. Public static void heapify. In this I will pass array int arr, after it int I value, after it int size of the given array. Right, so in this what I will do is that first of all I need to store the left value. Left is equals to 2 into I plus 1, right? So I have shown you in the properties, this is how we will calculate the left child and the right child. Int right is equals to 2 into I plus 2. Now after this I need to calculate the max value. Max index is equal to, let's say my max index is the root node. I am assuming that the max index is root node. Now after that I need to check if my left, I am writing the same thing but I am changing just the condition. I am changing less than to greater than, that's all. So if my size is less than size, if my left side is less than size and my ARR of left is greater than ARR of my max of IDX. If this is the case, then I will change the max IDX as left. Max IDX is equals to left. Now the same condition, but here the right will come. Right is less than size and ARR of right, ARR of right should be greater than ARR of max IDX. If this is the case, then I will change the max IDX as max IDX is equals to right. This is how I will calculate the max index. After calculating the max index, I need to check if my max index is not root. If I have assumed that you can see that in the top statement I have assumed that the max IDX is root. If it is not root, then I need to swap the maximum element with the root node, right? So if it is not the root value, then I need to perform swap step. I need to perform swapping step between maximum index and the ith index. So int temp is equals to ARR of max IDX. After it ARR of max IDX is equals to ARR of I, and ARR of I is equals to temp. Like this I will swap. Now after swapping I need to call the heapify function for the rest of the array. So I will call heapify and here I will pass the same max ID after it the size. Like this I will create my heapify function, and in the main function let me give the parameters which we have taken as example. So in the main program I have taken the example which we have taken. After it I am calling heap sort function, and heap sort will convert my given array into a sorted array. After it I am calling the heap sort, I am calling whatever the running a loop, and I am printing the elements, whatever the elements present in my array. Now let me save and run. So if I run this code, then I will get a sorted array in the ascending order. Now let me save and run. Here it is showing some kind of error. Here I need to give right. Yep. After that public sort static heap sort, here a curly brace. Now let me save and run. So you can see that I got the output as 1 2 3 4 5. So this is the array I have taken, and you can see that this is the unsorted array, and my heap sort is giving me output in the ascending order. Like this we will perform heap sort operation, right? So I hope I have understood the overall working of heap sort. So what I did is, first of all, I have converted my heap sort given array into max heap by heapify function. So you can see that here first of all I am running a loop and I am calling heapify function, and heapify function will give me max heap. Now after it I am performing the second step by running a loop. In the second step, first of all I need to swap the root element with the last element, and after swapping take the last element and delete it. And after deleting, again call heap sort function, and this will fix the whole heap. Like this I am performing the overall heap sort function. I hope you have understood the overall working of heap sort. Now let us talk about another interesting question. Now let us talk about another question, and the name of the question is nearby cars. So here user will give me a two-dimensional plane, and one more thing is that user will give me points. Let's say user has given me point as C0, C1, C2, C3, something like that, and these points represents the coordinate in the two-dimensional plane, and these points are the representation of the position of car. Okay, so these points are the position of different cars, and I am standing at origin. I need to calculate which car is nearer to me, and user will give me k value. Let's say k is equals to 3. If user has given me k is equals to 3, then from the origin which cars are nearer to me, I need to print any of these 3 cars. Let's say user has given me k is equals to 1, then I need to only print which car is nearest to me, and that car, the one point, I need to print that one point. Let's say for example I have 10 points, 10 cars, C0, C1, C2. These are the 10 different positions of different cars. Now user has given me k is equals to 3. It means that I need to, among these 10 cars, I need to only print the cars which are nearest to me, right? So let's say among 10 cars there are only 3 cars, and the position of that cars are C2, C3, C6. So I need to print C2, C6, okay, C5, whatever the cars may be. I need to print those positions. That's all. From the origin, which one is nearest to me, I need to print those cars. This is the basic asking of the question. So in the question, user, we are given n points in 2D plane which are locations of n cars, and if we are at origin, let us assume that we are standing at origin. From the origin, which car is nearest to us, which car in n cars, the given k cars, user will give us k cars, right? So I need to print those nearest k cars. Let's say 3 cars we have given, and user is asking only 2. So I will print the 2 cars which are nearest to me. So I hope you have understood the overall question. So let me make 5 points in two-dimensional plane. I hope you have studied coordinate geometry. So here let me make the points 1, 2, 3, 4, 5. 1, 2, 3, 4 and 5. Similarly, -1, -2, -3, -4 and -5. And here let me do the same, -1, -2, -3, -4, -5. Now here user has given me some input. Let's say at the C0 point, the location of C0 is 3, 3. So here you can see that this is 3 and this is 3. So this is the point location of C0, 3, 3. Similarly, C1 is 5, -1. It means that the x-axis 5 and the y-axis is 1. So here C1 is somewhere here, right? Here this is the location of 5, -1. Similarly, C2 is having x coordinate -2 and y coordinate as 4. So -2, 4. C2 is somewhere here. C2 is here. -2, 4, and C1 location is 3, 3. Now if you observe this diagram, I need to print the points which are nearest to me, not the farthest to me. So to calculate the nearest, to know which one is nearest, first of all, the first step is I need to calculate the distance from my position to that given point. So if I can able to calculate all the distances, then I will take the first point which is the least. After that I will take the second point which is the second least. Like this I will take the points. Now if you observe the overall diagram, let's say this is the x-axis, right? This is the x-axis we are having, and this is the y-axis. Now if you observe that this is the distance. Now let me move the y coordinate. If you move the y coordinate, then I will get a right angle triangle. This is y, this is x, and if you recall some mathematical stuff, then this distance will become root over x square plus y square. Okay, so I need to calculate this distance, and the distance which is minimum, which gives me this minimum value, that point will become my nearest point. Okay, I hope you are getting it. Now let us consider that this value root over x square plus y square, just root over, sorry, not root but x square plus y square is m. Now can I say that m is directly proportional to root m if m is positive? Let's say I am only taking mod. Okay, so if I am taking mod, I am only taking positive values, then mod m is directly proportional to root mod m. If it means that if m is increasing, then root m value will also get increased. Okay, so I need, let's say that here C naught has given me the answer, the distance, this answer, this distance, let's say let me call distance square. So C naught has given me distance square as m, and C1 has given me distance as n, and C2 has given me t. Now among these three distance, let's say m is the least, after n is the second one, after t is the third one. So my nearest points will become C0, C1, C2. Like this, in this order I will take my nearest points, and user has asked me only 2 points, so I will take the nearest 2 points, that are C0 and C1. Like this I will calculate. So the step 1 will be, first of all, calculate the distance. Talking about the approach, so first of all imagine, and we have the formula, that is, if user has given me the x coordinate and y coordinate, I will calculate the m value. And if I will calculate 3 different values, let's say this has given me m1, this has given me m2, and this has given me m3. Now after calculating all these 3 points, I will add these 3 points into my priority queue based on the m1, m2, m3 points. The point which has least m1, m2, m3 values will go into my priority queue first. So here what I will do is, talking about the approach, first of all I will calculate the square distance. This is nothing but m1, m2, m3, like this I will calculate my m points. Now after that, second thing will be, I will add that points, I will add that particular C0, C1, C2 points, I will add point into my priority queue based on, the priority will be based on this points, that is m1, m2, m3, which one is least, that point will go in first in my queue. After third point is that I will run a loop from I is equals to 0 to k, and whatever the elements present in my priority queue, I will print that. Like this is the very simple approach. So first of all I am calculating from my origin the given square distance. I am calculating this square distance. After that I am adding that points into my priority queue based on the square distances. Okay, and after adding, basically I am printing. I know that internally my priority queue will take the elements which is least. So here I don't need to sort, I don't need to apply any greedy algorithms. Let's say if you don't know priority queue, if you don't know the concept of heaps, then you will think of greedy algorithms. Oh, I need to apply some greedy algorithms here. Like this you will think. So we can say that priority queue makes our approach a little bit easier and very simple. So I hope you have understood the overall approach. Now let us code this thing. Let me create a class, because I am comparing objects, right? So if you recall the concept of priority queue in objects, which we have discussed in Heaps session 1, I have told you that priority can be set based on an interface called as comparable interface. So here I am comparing a car. Car is an object, the position of a car, and car is an object, right? So to compare object based on its square distance, I need to use comparable interface. For that I am creating a class, static class. Here let me give point as my class name, point, and I need to use comparable interface. So implements comparator, comparable, and here I need to pass my point, which class is being compared, point class is being compared here. Now in this, a point will have 2 things, its index, position, and x value, y value. X value, y value is basically position, after its square distance, after its index. So int x, after int y, position, after my square distance, int square distance, after int my idx, which index it is, whether it is C0, whether it is C1, like this I need to store distances. Now I will create a constructor, public point, let me write the point, and here let me pass the parameter as int x, initialization step, int x, int y, after int square distance, after int idx. Okay, now this dot idx, this dot x is equals to x, after this dot y, I am just initializing all the variables, is equals to y, after this dot square distance is equals to square distance. After this dot idx is equals to idx. Like this I'm creating a constructor. Now after creating constructor, I need to create a function to compare. On what basis I need to compare, right? So for that I'm creating a override function, public int. Now I'm writing compare to function, compare to, and here I'm comparing based on the square distance. So I will pass point and let me pass as p2, right? Now here I need to pass return this dot square distance minus p2 dot square distance, and this will sort my given object. This will like create a priority based on the square distance, and this will create an ascending order. Okay, I hope you have got it. Now let me give a statement terminator here. Now after creating this, in the main program, let me take the input parameters which I have taken. Now I have taken the points which I have taken in the example, exact same points, C0, C1, C2. Now after that I have taken the k value. Now what I'm gonna do is that I will create a priority queue, and in the priority queue I will pass point class. Let me give pq is equals to new priority queue. Now after that what I'm gonna do is that I will run a loop and I will calculate the distance, square distance, and I will add that particular point into my priority queue. So I will run a loop for int I is equals to 0 and I should be less than pts dot length after that I plus plus. In this square distance, int square distance is equals to, let me calculate the square distance. So square distance is nothing but x square, that is pts of I into pts of I. This is x. Now after calculating I need to add plus again pts of, here I need to give this is a two-dimensional, right? So pts of I comma 0 will become my x. After pts of I comma 0, right, this will become x. Now I need to calculate y, pts of y and 1. So this is my y pointer. So pt point of I comma 1, right? So this is my y point. Now I am calculating the square distance. Now I need to add that into my priority queue. So I will add pq dot add new priority queue, and here I will pass my x value as pts of I and 0. Similarly pts of I comma 1, and the square distance will remain the same after the index value I. Like this I am adding. Now after adding, what I will do is that I need to print the nearest k cards, right? So for that I will run a loop for int I is equals to 0 and I should be less than k, after that I plus plus. In this what I will do is that I will print system.out.print. Here let me give c and some space and pq dot remove dot idx. Like this I will like print the whatever the elements present in my given car, nearest elements. Okay, so let me save and run this. So it is showing some kind of error. Okay, here I need to give I is equals to, here I is equals to k. Okay, now let me save and run this again, and a little bit space here like this. Now let me save this thing, and again we are getting the output, but I'm just making it look good. So you can see that I got the output as C0 and C2, and that is the same answer we got. If you see the previous slide, you can see that the answers are C0 and C2, and like this we will calculate the overall like the nearest k points, the nearest k cars from the reference of origin. Like this we will calculate the nearest points from a given respective point. Okay, so in this what I have created is basically I have created a point and I have added the point object into my priority queue based on the square distance, right? So this is how we will calculate the nearest k cars. Now let us talk about another question. So the name of the question is we need to connect n ropes. So here the question is given n ropes, user will give us a n ropes of different lengths. So we have different lengths, let's say 10, 20. So this numbers represent the length of ropes. The task is to connect these rope into one rope. I need to connect all these ropes into one rope with minimum cost. Such that the cost to connect any two ropes is equals to the sum of their lengths. Let's say for example we are having two ropes. The first rope length is 4 and the second rope length is 3. Now if I add these two, to add these two ropes, the cost will become the sum of their lengths. So the cost will become 4 plus 3. So I need to add my ropes in such a way that at last I need to add all my ropes, but I should get my minimum cost. This adding operations will give me minimum cost. So here this is the basic asking of the question. So we need to add all the ropes, but this adding operation should be done with minimum cost, right? I hope you have understood the basic asking of the question. Now you can do this question using greedy algorithms. So what you will do is that you will sort the given array, whole given array, and you will take the least elements, and at each and every level you will keep on adding the two corresponding ropes like this. You can do, and I want you guys to stop the video, go to the greedy algorithms, understand greedy, and do the question with greedy algorithms. Here what I'm gonna do is I'm gonna use the concept of heaps and priority queue, and using the concept of heap and priority queue I'm gonna solve the question. Okay, so let us talk about how we're gonna do it. So here user has given me rope lengths and answer is 29. So for instance, let me keep the answer aside. Now let us understand what is the cost, how we will get cost. So for example, let's say I'm adding two rope, the length of the rope one is 2 and the second rope length is 3. So if I add these two, then my cost will become 5. If I'm adding the first rope and the second rope, if the first rope length is 5 and the second rope length is 4, then the cost will become 9. If the first rope cost is 9 and the second rope cost is 6, then the cost will become 15. Like this, the cost is totally dependent on the length of the rope. I am repeating again that whenever you are adding, this is my rope 1, this is my rope 2. So the adding cost is totally dependent on rope length, right? So can you extract one thing from this? That is, if the cost is dependent on a rope length, then I should take the rope initially which is less, because when I take the least length rope, my costing will get reduced. If I take the rope which is having the largest length, so as I keep on adding, my cost will get increased. Let me show you a diagrammatic representation also. For example, let's say that this is the array I'm having. This is the array I'm having 4, 3, 2, 6. So what I will do is that, let me clear the screen. Okay, so first of all I will take 2 after 3. The first rope length is 2 after 3. I will combine these two, so I will get a rope 5. Now after that 2 is completed, 3 is completed. Okay, now I will take the least. Which one is least? 4 is least. So I will take the fourth rope, I will combine these two, so I will get 9. Now 4 is also completed. Now I will take 6. So 6 is here, and I will combine these two, and finally I will get final rope length as 15. And you can see that I have iterated through each and every index of the rope, and the final length of the whole rope is 15. Now let us take a look at cost. So can you see that on the first step I am adding the both cost. So my cost, initially cost will be 5. Now here the cost will be, I am adding 2 ropes. So the cost will be here at each level 1, my cost will become, I am using the level concept such that it will become clear too. So when I am adding rope 2 and rope 3 at level 1, this is level 1. So my level 1 will give me cost 5. Now at level 2 my cost will become 5 plus 9. So 5 plus 9 will become 5 plus 4, it will become 9. Similarly, at level 3, my cost at level 3, the cost will be 9 plus 6, that will be 15. Now you can see that at each and every level I am getting some individual cost. Now I want you to look the diagram. So when you look the diagram, can I say that this 5, you can see that by adding this 2 nodes I am getting 5, and this 5 is repeating here, this 5 is repeating at the second level, and this 5 is repeating at the third level. And by adding 4 and 5 I am getting 9, and this 9 is repeating at the first level, and this 9 is repeating at the third level. So 5 is repeating at 3 levels, after that 9 is repeating at 2 levels. So the costing will also repeat, right? So can I write here that to calculate total cost, I have extracted the cost of each and every level, right? I have extracted the cost of each and every level. So to calculate the total cost, I need to add up all the level costs. So here the total cost will become total cost is equals to level 1 cost plus level 2 cost plus level 3 cost. This will become my total cost. It means that 5 plus 9 plus 15, that will give me 29, and this will become my total cost. I hope you have understood. So what I am doing is that I am taking the least value, the rope which is having the least length, I am taking them, adding it. So let me show you the dry run also. For example, I have shown you the dry run for this. Now let me take the diagram as this. So here you can see that my array is 2, 3, 3, 4, 6. Now what I am doing is that I am taking the least rope. You can see that the rope is least 2. After that I am taking the second least. So here 2 is I am taken, after that I am taking 3. Let's say I am taking 3. So 2, 3, I am combining these 2. So this will give me 5. Right? Now my array, after combining this, my array will become, I am adding these 2. So these 2 elements will become one element because I have added them, I have used them. So my array will become 5, 3, 4, 6. Now you can see that this is the rope and this is the array I am having. Now I will take the least element. Which one is least? I will 3 is least. So I will take 3 and I will combine these 2. Now you can see that I have combined these 2. So my array will become 8, 4, 6. So I am having 8. After that, which one is least? 4 is least. So I will take 4 here. So I will take 4 and I am combining these 2. So this will give me 12, and my final array, whatever the rope left in my array, is 6. So I will add 6 here. Now this will give me what? This will give me 18. So you can see that 18. Now at level 1 my cost is 5, at level 2 my cost is 8, at level 3 my cost is 12, at final level my cost is 18. So to calculate the total cost, I need to add 5 plus 8 plus 12 plus 18. So this will give me total cost. Right? So I hope I have understood the overall approach of it. So what I am doing is that I am taking the rope which is least. I am taking 2 ropes which is least, combining them, and this will become a single rope. So instead of having 2 different elements, I am replacing these 2 different elements with one element. And I am taking that one element and next least element. Like this I am calculating the least cost at each and every level. After calculating the least cost at each and every level, I am adding all these levels to calculate the total length, the total cost. I hope I have understood the overall approach. Now let us code this thing. Now you can see that in the main program I have taken the example which we have dry run. Now after that I am creating a priority queue because I will take the least rope value, the least length which is having in my rope, I will take that. So first of all I will create an integer type priority queue, integer. Let me give pq as my name, new priority queue. Now after that I will run a loop, and as I run I will add the ropes which is having the least length into my priority queue. So int I is equals to 0 and I should be less than ropes dot length. After that I plus plus. In this what I will do is that I will add elements into my priority queue based on the rope's length, rope of I. Now after that, what I will do is that I will create a cost variable int cost is equals to 0. Initially the total cost is 0. Now after that, what I will do is that I will run an internal loop while my priority queue is not empty. I keep on taking the least element and I will add them both. And after that, let me show you a diagrammatic representation also, such that it will become clear to you guys. So here going back to this, okay, so here let me write this. Okay, so what I'm doing is that, let me show you. I'm creating a priority queue. Let's say this is my priority queue. Now I'm adding the elements into my priority queue. For example, I'm taking this. So I'm adding, and my adding will take place in my priority queue based on the priority. So my priority queue will take the least elements. So my output will be, my input will be, first of all 2 will come here, after 3, after 4, after 6. Now I'm taking these 2 elements, adding them both. After adding, I will store in min value. Whatever I will create a variable, I will store the 2 elements. So I will store 5. After that, I will remove these 2. So my queue will become 4 and 6. Now I will add 5 into this. So I will add 5 into this, and my priority queue will make sure that 4, 5 and 6. My priority queue will make sure to maintain this order. Now I will take these 2. I will store again in a min variable. Min is 9. Now I will take this and insert, and as I insert, I will remove these 2. So you can see that I will remove 5 and 4. Now I am having 6. After that, 9 is here. Now I will take these 2. I will store its min. Right? I will store its min, that is 15, and I will remove these 2. I will remove these 2. Now 15 I am having. Right? So you can see that I am having, first of all, min 5, 9. And 15. So if I am having one element, so I will remove that also, and whatever the elements I am getting in my min, I will add those into my total cost. So I will create, in my while loop, I will create cost plus is equals to min. So at each and every iteration, I keep on adding 5, 9, 15 into my cost. I hope you got the logic. So this min will calculate the minimum cost at each and every level, and my cost variable will store the total cost. So going back to the code, so I will create, while my priority queue is not empty, I will keep on removing the first 2 elements. So here int min is equals to pq dot remove. I will removing, after that I need to take the second minimum. So min 2 is equals to pq dot remove. I'm taking the second min. Now I will add cost plus is equals to min 1 plus min 2, and after that I will add pq dot add min 1 plus min 2. I am adding this again into my priority queue, min 2. Like this I am adding. Now after running a loop, after running the whole loop, I will come back, and here I will print in the function, I will print minimum cost of adding all ropes is equals to, and I will print my cost. Basically here I will print my cost. That's all. Like this I will print my cost. Here let me give cost outside. Okay, now let me save and run this. So if I run this, then I should get my total cost. Okay, it is showing some kind of error. I think it is a conditional error. Okay, so here I need to keep on removing the elements until I get a at least in my old priority queue. If I am having one element, then I need to stop, because there is no min. There is a min value, but there is no min 2. If there is no min 2, then I need to like stop my loop. So if my pq dot size is greater than 1, then and only I will run my loop, else I will not run my loop. So let me save and run. So here you can see that I got the total cost for this particular array. My total cost is 43. So this is how I will calculate the total cost to connect the given n elements, given n ropes in my array. So I hope I have understood the overall approach. Now let us talk about another interesting question. So in the question, user will give us a m cross n 2-dimensional matrix. In the matrix, all the elements are binary elements. What I mean by binary elements is that in the whole matrix, either it can store 0 or it can store 1. if it is storing 0, then it represents a civilian. If it is storing 1, then it represents a soldier. Right? Now I need to tell that whether that particular given row is a weak row or not, and how we can tell that whether the given row is weak or not based on these two conditions. The first condition is for a row I is weaker, is said to be weaker than row j if one of the following conditions is true, and that condition are condition 1. The number of soldiers in row I is less than the number of soldiers in row j. It means that, for example, let's say that I am at the ith row. Let's say this is the ith row, and in the ith row the number of soldiers, the number of ones occurred in that row is, let's say, x, and at the next immediate row or the next row, whatever the next row I am getting, let's say it is jth row. So in the jth row I am having soldiers y. Now if I am getting condition that my x is less than y, then the ith row is a weak row. It is said to be a weak row. This is condition number 1. The condition number 2 is that if both the number of soldiers are same, for example, in the ith row I am having x soldiers, in the jth row also I am having x soldiers, but if I is less than j, then ith row is the weak row. Right? I hope you have understood. Ith row is said to be a weak row. This is the second condition. Now user has given me a two-dimensional array, and I need to tell that this is the row 0, this is row 0, row 2, row 1, row 2, row 3, right? Row 0, row 1, row 2, row 3, right? Now I need to tell which row is the weakest. This is row 0, row 1, row 2 and row 3. Now my condition is that, let's say that ith row, jth row, okay? So ith row is coming previous to jth row, okay? Now let's say that in ith row the number of soldiers is x, in jth row the number of soldiers are y. Now if x is less than y, then that particular ith row is a weak row. Okay, this is condition number 1. Condition number 2 is that if both in I and j are the number of soldiers are same, but I is coming prior to jth row, then I is a weak row. Okay, got my point? Now let us observe the given array. So if you observe the given array, you know, this is, for example, for instance, let us say that this is my ith row and this is my jth row. Here the number of soldiers are 1. Here the number of soldiers are 4. You can see that 1 is less than 4. If this is the condition, I am satisfying the condition 1. So row 0 will become a weak row. Okay. Now if you observe row 2, this is, let's say this is ith row and this is jth row. Here the number of soldiers are 1. Here the number of soldiers are also 1. But here you can see that it is satisfying the second condition. That is why row 2 will also become the weak row. So the answer for this will be row 0 and row 2. Now let us talk about the approach. I hope you have understood the overall question. Now let us talk about the approach. So can I say that number of soldiers, if it is higher, if the number of soldiers is higher, then the weakness is low. If, for example, for a given row, if my number of soldiers are more, then it is a less weak row, right? It is not that much weaker row when compared to a row which is having nil soldiers, right? So the weakness is totally dependent on number of soldiers, right? So what I will do is that I will create a priority queue. I will create a priority queue for row object. For this row object, I will create row object and I will add rows based on the number of soldiers. So the priority is defined for the number of soldiers. Okay, so here you can see that initially row 0 is having least number of soldiers, so I will add row 0. After that row 2, after that row 3, after that row 4. Now after that I will keep on removing the elements and you can see that I will get the elements in the weakness order. As I am moving from left to right, the weakness is reducing. And if the user has asked me for only 2, then I will only print 2 elements in my priority queue. Like this is very simple question, right? Now let us code this thing. Now first of all, what I'm gonna do is that I will create a static class to create a row object, because I'm adding my rows into my priority queue, and this adding of objects into my priority queue will take place based on number of soldiers. If number of soldiers is same, then based on the index of that particular row. So first of all, I will create a class, static class. Let me give the name as row, and here implements comparable interface, and let me give row here, row. Now what I will do is that first of all, every row will have number of soldiers. So here int number of soldiers, after that int index idx. Now first of all, let me create a constructor public row. In this I will pass int soldiers, after that int idx, and I'm gonna initialize it. So this dot soldiers is equals to soldier, this dot soldier is equals to soldier, after this dot idx is equals to idx. Now coming to my comparable, what are the priority I'm creating. So to create priority, first of all I need to override my function public compare to, public int compare to. Here I will pass my row object. So let me pass my row, let me give add to object. So here I will compare based on my number of soldiers. So return this dot soldiers minus r2 dot soldiers. So here my priority queue will take the soldiers which it is having least. So it will store the rows in the ascending order based on number of soldiers. Now the second condition says that if both soldiers are same, then my priority should be based on the row number. So for that I am creating a condition, if my this dot soldier is equals to r2 dot soldier. If both are same, then what I will do is that I will create a priority based on the rank, the index. So return this dot idx minus return this dot idx minus return this dot r2 dot idx. So based on indexing I will create priority. If both are not same, then this will come in else block, and this else block, in the else block I will create priority based on soldiers, number of count of soldiers. Now in the main program, let me remove this. After removing here, in the main program what I'm gonna do is I will take the example which we have taken. So I have taken the example which we dry run before. In this I have created army of two-dimensional army array, and it will store the number of soldiers along with civilians, and I have taken for which rows I have to print. So for kth rows I need to print the answer. So what I'm gonna do is that I will create a priority queue, and here in the place of primitive data type I'm gonna store the object. So the row, this priority queue will store the rows based on number of soldiers and the indexes. So pq is equals to new priority queue. Now after creating priority queue, I will run a loop for int I is equals to 0, and I should be less than army dot length, after that I plus plus. And to keep track of amount of number of soldiers which we are having for a particular row, I will create a variable called as count. So int count is equals to 0, and now I need to traverse through each and every column. So for that I am running my internal loop for int j is equals to 0, and j should be less than army of first row dot length. Now after that j plus plus, I'm gonna do is that I will increment the count value at each and every occurrence of 1. Okay, so army of I of j, I am creating a ternary variable here, ternary operator. If this is 1, then I will put 1 here, I will increment it by 1, or I will put it 0. So this is a ternary operator. Here what I'm gonna do, I'm doing is that first of all I'm checking if it is 1, then I will increment it by 1. If it is not equals to 1, then I won't change anything, I will put it 0, right? Like this I am doing. Now after like incrementing, I will come out of my inner loop. After that I will add pq.add, I will add my row, I will create here new row. Here I will pass my count, after its index I. Like this I will add objects into my priority queue. Now after adding objects into my priority queue, what I'm gonna do is that I will come out of my outer loop and again I will run my inner loop. Int I is equals to 0 and I should be less than k now, because I need to print the first kth elements. Now after that I plus plus. In this what I will do is that I will print system.out.print. Here let me give r a space, no need for space, now plus pq.remove dot index. I will print the ith row index plus a space here, like this. Now if I run this and run, if my output will be r0 and r2. Now let me save and run. It is showing some kind of error. Here I need to give a statement terminator. Okay, now let me save and run. So if I run, then my output will be the first two weakest rows. You can see that my first two weakest rows are r0 and r2. This is how I will calculate the objects. First I am inserting objects into my priority queue and I am creating the priority based on number of soldiers and the index. So if the number of soldiers are same, then I am creating the priority based on indexing. If both are not same, then the priority queue will get created on soldiers based on number of soldiers. Now in the main program what I am doing is I have created priority queue, running my loop, and whenever I am occurring a soldier, I am incrementing the count of soldier. Now as I increment the count of soldier, I am adding that into my priority queue, and I know that internally my priority queue will take the will add my element which has the least number of soldiers first. After the like this, in the ascending order, in the ascending fashion, my rows will get filled in my priority queue. Now after that I am running my loop and I am printing the first weak rows, first kth weak rows, and I know that in my priority queue has already assigned my elements in the ascending order. The first row will have the least number of soldiers. If it has the least number of soldiers, then it is given that it is a weak row. So this is why I am using the concept of priority queue. And one more thing is that you can do the same thing we did connecting n ropes. We did weak soldiers, right? These two questions can be done using greedy algorithms, but in that it will become a kind of complex and it's kind of hard to think. When compared to priority queue is very easy. You're creating priority queue, adding in them, and finally you're getting the answer. So you can say that you can do some problems based on priority queue. You can do the same problems using greedy algorithms also, and which one, depending on which one is easy at that point, you will choose that. So I hope you have understood the overall, like what is priority queue, what is the working of heaps, all those kind of things. Now in the next chapter we are gonna talk about very interesting concept, and the concept is hashing. With that being said, I will see you in the next one.